Okay. Hey, everybody. Thank you all for being here, and I want to thank Melanie and Shelley for inviting me to participate in this wonderful conference. I'm a scientist, a physicist, and so I'm a little bit out of place in this place, but I feel I spent most of my life being out of place. So it's kind of a good feeling, familiar feeling. And I'm going to talk about science, but science, I hope, about issues that you're interested in and concerned about. I want to begin this talk by acknowledging that, as a scientist, that scientists have more or less completely effed up climate change. And so I want to make that an acknowledgement, and I'll explain it in a moment, but I just want to emphasize that I feel any sort of reasonable discussion about global warming and climate change and what the future holds with respect to those issues has to start with that kind of acknowledgement. It's basically, as a scientist, it's an empirical fact that basically what has been done so far with respect to climate change, which has mostly been in the hands of scientists, has been a failure. And so, just to make that story a little bit more complete, back in the last millennium, we could argue a little bit about exactly when decisions were made about how to approach climate change, global warming. It was recognized as a problem. And basically, the decision was made, which is completely expected, that it would be treated as other kinds of environmental disasters that capitalism and colonialism had given rise to. That is, it would be treated as a problem to be managed with tools like cost-benefit analyses. And so scientists were handed the responsibility to basically look at what the future might hold with respect to global warming and climate change, and make predictions about that, and also within STEM communities to figure out what to do about it. And not surprisingly, they came up with a fairly narrow range of future possibilities for things like globally average temperature, sea level rise, and so forth, and a series of solutions that were based on technology. So those are the futures that scientists have envisioned for us. As we can see most recently with the coup in Bolivia, which was in part about the vast resources there of lithium to be used for electric car batteries. Basically, this technological future that scientists have given us is basically about business as usual. It's about taking a exploitation of the atmosphere and converting it into exploitation of other parts of the environment and the peopled environment. And of course, these solutions that scientists have given us were basically designed to foreclose any possibility of any sort of real systemic change. So what I want to talk about today really briefly is three things. First of all, I want to situate resistance in societal environmental interactions. I want to understand the role of resistance. And I'll do that using some scientific methodologies. The second thing I want to do is go back and basically talk about what is global warming, what is it really? Look at it a little bit more closely. And with that alternative analysis, then I want to suggest a possible alternative future. So as I said, I'm a scientist, I'm a physicist, earth scientist, and I'm interested in research-wise in connecting societal behavior to non-human environmental processes. And so I want to be able to develop models of those, develop ideas about those, and also develop ways of measuring those kinds of interactions in a scientific sense. The methodology I use is something that's called complex systems, and it has the advantage that we could take societal behavior and environmental behavior and put them in that common framework. It also has a really cool aspect to it, which is very useful, and that is that the same methods within complex systems that can be used to study things in a quantitative sense can also be used to study them in a qualitative sense. And that's really important because, like, most of what we know about societies and the environment is qualitative. And my scientific colleagues are very interested in the quantitative side, but they reject any studies of the qualitative aspects of these systems. And so the beauty of complex systems is that it allows us to approach both sides of both sets of data, of both ways of looking at societal environmental interactions. So I want to, as I said, I want to focus on resistance, and I'm thinking of resistance as a process of stepping outside a system to oppose it or change it. And the scientific concept that I want to use to analyze resistance here today is called dissipation. And that's a concept that you're all familiar with. It's often called friction. Basically, if you just rub your hands together, you're engaging in dissipated processes. When you rub your hands together, you're converting the coherent motion of your hands as they're rubbing against each other partially into random motions at smaller scales of the molecules in your skin. And basically, as those molecules gain more energy, as you're doing that conversion, basically your skin heats up and the temperature rises. So basically, dissipation in general is this conversion of coherent motion at one larger scale into random motions at a smaller scale. And you can think of it, just to have a way of picturing it, is kind of like entering a maze. As you go into the maze, you have a coherent motion, a coherent speed and direction. But then once you get into the maze, the walls force you to start moving in directions that you don't really want to go. And so your coherent motion as you go in is converted into random motion by interaction with the maze. And so that's a dissipated process. On the short term, basically moving into the maze, your coherent motion is disrupted. So dissipation on the short term is disrupted. But on the longer term, basically your motion now becomes basically mixed with the motion of the maze. It's basically your coherent motion gets damped out. So those are characteristics of dissipation. And when we're looking at various processes, we can look to identify those characteristics in those processes. The typical way to talk about dissipation among scientists is kind of that physicsy way that I just used of like generating heat as you're rubbing your hands together. But we can also see dissipation in social contexts as well. An example is basically communication. So right now I'm speaking to you, or I could be speaking to you on a phone, and basically I'm transmitting information to you. It turns out in a quantitative sense, since I'm a scientist, I'll tell you that I'm transmitting about 39 bits of information per second. Sorry for being a little bit too sciencey there, but basically that's what's happening. So that's the information that you're receiving. But I'm actually putting out way more information in the sound waves of my voice and so forth. And those are traveling to you. But in the process of getting to you and being interpreted by your brain, all that extra information gets lost. It actually turns out that when you're speaking, you have something like 1,000 times as much information as actually gets transmitted. So basically, vocal communication is a very dissipated process. Most of those bits of information that I'm putting out get disrupted and damped in the process of getting to your brain. Texting or writing things is actually much less dissipative. We're really only putting out about 3 times as much information as actually gets transmitted. So that's one form of social dissipation. Another form is actually resistance movements. Activism can be dissipative. So if you think about the dominant system trying to accomplish something, having some pathway to do that, for example, extracting oil from the ground, transporting it by pipeline, and then burning it to generate electricity. Basically, resistance against different elements of that pathway, of that process, on short time scales disrupts that pathway. But on long time scales, it basically bleeds out a certain fraction of that coherent motion that the society is trying to accomplish. And so social resistance on short time scales, over the short term, is disruptive, but over the long term, it's dissipative. Another thing, a few other points I want to make about dissipation. In our capitalist, colonialist society, we're very much devoted to, and I see this especially being in STEM, to making things efficient and using technology to make things efficient. And basically, those things basically reduce the dissipation, the kind of natural dissipation that's present in our social and environmental contexts. So basically, efficiency and technology reduce dissipation. And the last point I want to make about dissipation is dissipation promotes stability. So if you think about an unchanging climate is stable. A warming climate is unstable. And basically, when I say that dissipation promotes stability, that means if you're in a situation where you have high rates of dissipation, we should expect that system, climate or whatever, to be stable. And if there are low rates of dissipation, we would expect it to be unstable. So now I want to put all that information together. So the idea that technology and efficiency reduces dissipation, and also that resistance is a form of dissipation. And so I kind of have this loop here. Sorry, it's kind of complicated, but I'm just going to go through it. So up at the top, we have the capitalist colonialist system using technology to make things more efficient. That reduces dissipation. For example, using fracking technology to facilitate the extraction of oil and gas from shale rock. That's kind of a technological solution that effectively reduces dissipation in our relationship to the environment. This reduction of dissipation, because dissipation is stabilizing, it leads to instability. So it creates this environmental and social destruction. That those instabilities then create an environment for injustices. Injustices that might, for example, in the case of fracking, one of the injustices that has come out of that is all the injustices associated with the Dakota Access Pipeline. Those injustices then spawn resistance movements within the communities in which they're occurring. Those resistance movements are dissipative. On short time scales, over the short term, they're disrupting the dominant society. Over the long time scales, they're injecting dissipation. So basically, the role of dissipation then, as illustrated with this loop, is that over the short term, resistance is disruptive. And sometimes and I don't want to minimize this, oftentimes it can lead to accommodations of the society to basically reduce the level of injustices. But on short terms, it's doing that. But over the long term, it's actually doing something that we really don't want it to do. That is, it's acting to stabilize and lock in the capitalist colonialist system. So I'm just going to skip that. And I want to move then to my second point, which is kind of looking at what is global warming. And the standard answer to that is that global warming is caused by humans. It's caused through the emission of greenhouse gases through burning of fossil fuels, greenhouse effects, increases temperatures of the atmosphere and ocean, and causes all sorts of bad things to happen. So that's the standard answer. And I want to basically question that. And I'm going to question that by first looking a little bit more carefully at what is social resistance. So I'm just going to kind of go through this quickly, and I apologize for that. But social resistance is colonialism and capitalism's, or it's a response to colonialism and capitalism's exploitation. It's highly heterogeneous in space and time, but there are some patterns, behavioral patterns, dynamical patterns that we can identify. On the short term, it's disruptive, as we've discussed, and the state response is repression. Sometimes that repression can become over the longer haul as well. And the intermediate term, the resistance can cause the state to accommodate it, but the state at the same time is attempting to co-opt resistance. So resistance has to be creatively reinvent itself to become more illegible and less able to be co-opted. And finally, on longer time scales, it's dissipative, which promotes the stability of the system. Now I want to look at global warming in the same way. I want to look at as Earth's response to colonialism and capitalism's exploitation of the environment. So on short time scales, global warming is disruptive. It creates these big events like mega hurricanes. Also, you get repression of events of global warming. For example, in fire repression of wildfires, or over longer time scales, various forms of geoengineering. On the medium scale, basically global warming is nudging the system to make accommodations, but it's also being co-opted as the ice in the Arctic is melting, the oil companies are moving in to drill. We don't normally think of the Earth as being creative, but global warming has a lot of aspects to it which are quite illegible. You've heard of tipping points, for example, which are really hard to predict. And over the longer time scales, we would expect that these global warming disruptions, which are just beginning, will have a dissipative effect. And the question is whether that will be stabilizing or not. And that's the question that I want to address just briefly at the end here. So I just want to point out one thing about climate change activism is that almost ubiquitously within climate change activism, there's this concept that global warming is something to be avoided, to be minimized. It's something that's bad. And I just want to go back to this previous slide and emphasize that what I'm saying here on this slide is that Earth's responses to this exploitation dynamically, in a scientific sense, look very much like resistance. So we could think about global warming as a form of Earth's resistance to the exploitation of its environment, of its atmosphere. So I want to suggest, just to conclude, that a potential social resistance strategy is, instead of opposing climate change or painting it as something that's negative, social resistance movements could stand in solidarity with Earth and basically support Earth's resistance against the exploitation against it. There are advantages to this, including the fact that the Earth is the most powerful entity in this struggle. And what that would mean is that basically saying no to colonialist, capitalist accommodations and co-optation of climate change, it would, because marginalized peoples are those who are most likely to be impacted by Earth's resistance, it would mean saying yes to solidarity with those marginalized people. But perhaps most significantly, it would, because of the power of Earth as an actor in this struggle, it would offer the potential, instead of climate activism pushing the existing system to abandon its exploitation of the atmosphere and transfer that exploitation to somewhere else, to actually change, result in a widespread radical system change that would move away from exploitation. So in summary, I argued that social resistance on the short term disrupts, but on the long term does this thing that we're not very happy about, that is, it acts to stabilize the system. And in a sense, it puts social resistance in a rut over the long term in terms of significant system change. Secondly, I argued that from a scientific perspective, the behavior of global warming is very similar to the behavior of social resistance. So we could think of global warming as Earth's resistance. And thirdly, I argued that potential strategy for social resistance is to join in solidarity with Earth, to leverage Earth's power and its resistance to force system change. And I just want to note that being in solidarity with Earth is not something that's new. Indigenous people have been doing it more or less forever. Thank you.